Yo, what's up, everybody? Welcome back. Today we are day one of trying to write a Wayland window manager from scratch. No dependencies, very few dependencies, basically just drivers. But no lib Wayland, no WL roots, none of that crap. We're just gonna like raw dog it ourselves. The kind of like intent here is we've been kind of investigating the idea of writing an Android operating system. Sorry, not an Android operating system, an Android-like operating system, a Linux distro for our phone. And one of the first things that we're gonna need to do there is get some sort of like app launcher up and running, which means that we're gonna have to talk to the drivers on the phone, which are going to be significantly different than the drivers on a desktop. But I want to like understand before we get there. What the like desktop correct version of this thing looks like, right? And then we'll understand a little better what has to change and what interfaces we really want and all of that stuff. So I kind of want to write like a desktop window manager first. And then on top of that, I think that it would be fun to have some sort of like lightweight window manager that also has like fun effects. I think that I've had problems with multiple window managers in the past with having something that's like high frame rate enough and low latency enough to be able to like play FPS games at 144 hertz. Like I can just feel when I use GNOME that like there is extra latency that there's not supposed to be. And so I think having like control over the whole stack there will be like a fun project, as well as just like, we don't need good reasons. We just need to pretend we have good reasons so that you guys in this intro think that I'm doing something sane. Okay, that's all. And we're dropping the facade. Okay, I just want to do it. So we've done some previous work in this before. We have done this raw dogging Linux graphics. So I think we have an example in this virtual machine where we have an example of getting a thing up on the screen, right? We've done this before, and so we're going to kind of start from that guy. This is probably on YouTube. If you look up raw dogging Linux graphics, you'll probably find this video where we kind of did that setup. And then we've also written a Wayland client before, right? So we have this guy. This guy has like no dependencies, basically. Let's see, LDD zig out bin Wayland client. Well, it looks a little bit more, but he's basically linking against GBM and EGL and OpenGL. So like Mesa, essentially. And I think the rest of these things are kind of like, what's it called? Like dependencies from dependencies. I don't know why they're all there. But really, we were basically focusing on basically just using the system OpenGL. You kind of have to accept some amount of dependencies when you do this kind of thing, because the Linux driver stack is like kind of in user space partially as well. So like you have to depend on Mesa, right? So we've kind of got this guy, and so between the information that we have from both of those projects, we should be able to write some sort of like sane Wayland server, I think. My understanding of what we have to do, based off of those two previous implementations of things, is, let's start. Okay, so Wayland client, our little boy with the monkey in him. Whoop, 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 whoop. This guy. Our client, he initializes himself by talking to some compositor. In our case right now, it's Kwin. In the future, it will be us, right? Kwin kind of he puts a socket somewhere in hand wavy, like xdg runtime dir, like an environment variable, runtime dir / like Wayland 0 or something. Wayland 0.sock. I don't know. It's like something along these lines. We're gonna have to double check. But this is like a Unix socket. We connect to this guy and we say a bunch of like Wayland protocol stuff. We start chatting with that boy, right? And we're gonna ask him to like make us a window, essentially, right? So he's gonna be like, "Oh, you asked me for a window? Okay, here you go. I've put a window here. Can you tell me what to do with that window? You need to like put some stuff in there, right?" So we also kind of talk to the GPU drivers. So over kind of somewhere else, we go. There's this project libgbm. This is part of Mesa, which is kind of like GPU open source GPU drivers. So this guy owns like he owns all sorts of stuff. He owns like a Vulkan, right? Vulkan. He owns OpenGL. He owns EGL, which is like kind of like platform init stuff for OpenGL. He owns like all sorts of stuff, right? He owns like talking to like kernel drivers, where kernel drivers are like low level, basically like buffer management, maybe like GPU dispatch calls. But like if you call like OpenGL draw arrays, that goes through like this whole stack of shit, and Mesa kind of owns all of that. Mesa is just like one implementation, but he's the implementation that you're going to hit on most of your Linux GPUs, right? NVIDIA being the exception, but fuck them, you know? So one of the things that Mesa exports is this thing called GBM. NVIDIA does also support this. GBM is kind of like, I think it stands for something buffer management, general buffer management, generic buffer management. That would be my guess. I don't really know. But this thing is like kind of your abstraction for, hey, I want to buffer on the GPU and I want to like render to that thing, right? So what we do in our Wayland client is we create like a new GBM surface. So we open like a card, dev DRI card 0. We just open this shit and say, GBM, could you make us like a surface for rendering? And on that surface, could we get like the front buffer, right? So after we render in OpenGL land, or I guess before this, we say, could we create an OpenGL context from this thing? So we call like EGL in it, and we pass him our surface, right? So the stack is right now GBM first into EGL second. And now once we have EGL initialized this thing, we just do like normal OpenGL shit. You know, OpenGL draw stuff, right? We draw our monkey. And then we go, okay, we need to display this monkey now. How do we do that? Well, because EGL is drawing to this surface that is owned by GBM, we can say, GBM, get me the front buffer. Like, can you give me front buffer? Right? And he's going to tell us a bunch of stuff. Like, these are the parameters of the buffer. It's its width, its height, it's like how its color format, and like maybe a bunch of like extra GPU flags that we might want to pass around. But most importantly, he also gives us a file descriptor. And you go like, file descriptor, what the fuck? Like, how is our front buff a file? And it's like, there's this project called DRI Prime. And it's basically a common format in Linux for you to share GPU buffers between processes. So the way you do that is you like create a file descriptor for this buffer and you like hook it over the network. You go, you know, all of this stuff, whoop, send them over to Kwin, right? And now Kwin goes, okay, GBM, I would like to import now, right? Import that thing, and then he can take the thing that we import with the GPU buffer from over here, and he just has it over here now. Great. Now he wants to like draw that stuff in the window that he created, right? So he does something like he's done a bunch of like low level GPU initialization before this, right? So he's done something like okay. Kernel mode setting. This picture is going to be very useful for us. So from the other side, when you're like sitting at this window, right? You've booted your Linux desktop. You just see like a black screen. How do you get from here to like drawing stuff, right? The answer is basically this pipeline. So you have like this is a virtual machine, but if you weren't on a virtual machine, you would kind of start with like your monitor, right? Your monitor is sitting over here, and it is like plugged in to, in my case, like a desktop tower, right? Right? And my GPU is like sitting in that desktop tower, and he's connected on by PCI to the motherboard, and like the motherboard eventually connects to the CPU, or sorry, the PCI lines eventually connect to the CPU. So like kind of like there's like a CPU over here, right? And he is running Linux kernel, right? Linux is kind of sitting on this thing, right? And he can talk to the GPU over PCI. Keep that in mind. So this is kind of a way to model this, right? So they have connectors, right? DRM connectors, these are like the physical ports on the back of the GPU that go to monitors. An encoder is like a thing that lives in the GPU that like takes data and turns it into like wiggly lines over here, right? This is some protocol, some like HDMI protocol where you have a bunch of digital signal going over this wire. The encoder is like the piece of hardware in the GPU that does that, right? There is a CRTC, they call it, cathode ray tube controller, because back in the day, your monitors weren't flat and skinny. They were like big fat boys with a little like ray gun that shot out the back, right? Old style TVs and shit. So this is kind of like a name from back here, but this is basically a thing that lives in the kernel that says like, I want to control display output. And to do that, I'm going to take, data from multiple sources, a couple planes, and I'm going to like tell the cathode ray tube to put those out. So I have this controller. The controller is going to like figure out where everything's going to go. And then it's going to pass it to the encoders. The encoders are going to send the fucking data over the wire, and then it's going to show on the monitor. So all of this to say, is like the initialization for graphics on Kwin's side is like, basically walk this backwards, right? He's going to be like, oh, I have some monitor. Which monitor should I use? There's probably like a preferred port on the GPU. Hey, GPU, could you tell me which one that is? I'll get an encoder. Hey, now that I have an encoder, which like controller do I use for that thing? Because there's going to be multiple of these, maybe. And then he's going to say, hey, this controller, I need to like feed it some data. Well, the data comes in like planes, which are basically like, you have like hardware composition, right? So if you have like 4 windows on the screen, maybe the GPU can like directly scan those out without you having to do like a re-encode to like merge all the windows together. And these planes come from buffers, and these buffers are the thing we sent over the wire. So that is the context for everything. DRM shit, right? So the flow is both Kwin and, well, the client, he initializes OpenGL in a way where he can extract buffers, in a way that he can send those buffers over network, Unix socket, so like kind of network, kind of not, through the kernel to some other process. That other process goes, yum, 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 file descriptor, let me also use GBM, like, so I've got like kind of like partial OpenGL initialization. He doesn't necessarily have to have OpenGL, if I understand correctly, but he does need like the buffer management stuff. So he's got like GBM here, bring it over here. I've got this thing as a buffer object. Somehow he needs to import that into like DRM land to convert it into like a DRM frame buffer. He then feeds that DRM frame buffer through like this system, and it shows up on the screen. That's my understanding. Could be kind of wrong, right? But like that's my understanding right now. So we need to implement something that's like that. So the plan of action is to set up a server that like talks Wayland, right? The client is going to say a bunch of stuff. We have to interpret that thing. We haven't talked about the Wayland protocol at all, but hand wavy, there's a bunch of like XML files that describe what Wayland is supposed to look like, right? There's like a bunch of interfaces on here, and they all come in XML. And so like the thing that we've done in our client is we like take this XML file and we eat it up and go yum 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 Wayland stuff, and then we like spit out a bunch of Zig code that can speak this over a Unix socket. Hand wavy, that's like the previous work here. So our server is going to set up a server, get some connections, talk Wayland, and then at some point we're going to get a bunch of messages that we have to handle in some way for the client to be happy. So we will try to do that. Then the client is going to send us some GPU buffers, so we're going to like look at those and ingest them correctly. And then we got to render the client full screen. Probably around here, like virtual machine time, right? But kind of everything up until we try to render, we can probably do just like locally without trying to complicate things. So I think that's the play. Long ass intro. But there's a lot of context to catch up on, so I didn't really want to like, leave you guys in the dust behind. You guys got to know what I know, which is maybe a lot, maybe not. I don't fucking know, dude. Okay. So let's start by making a little new project. I think we're going to work in the same repo as our Wayland client because there's going to be like a lot of common code that is useful to use from that thing. I think eventually we are going to have to do some sort of like splitting out here because like the Wayland abstractions and the window system for the client and the server, those are going to end up being like 3 repos probably. But for now, it's all going to live in one spot because it's easier for now. So let us add some sort of server project. He's probably gonna want some Wayland bindings and some Wayland IO shit, probably. But he's probably not gonna want a client. So let's do this. Const WM, probably, for window manager. Try builder make WM. And he's gonna take in the Wayland IO shit as well as the Wayland bindings. And I guess we will try to install that thing? I don't know. I don't know, man. You can't fucking... Don't expect me to know what's going on. Make WM. So he takes in the stuff that was taken in here. Boom. And he's gotta like make a thing. So I guess it's probably gonna look like something. I don't know what yet. We're going to make an executable that's like swim. Sphere for swimming. We're going swimming. And this is from source swim. Main, I guess. Sure. And we are going to pull in, for now, I guess, root module, add import WIO with from WLIO, and Wayland bindings from bindings, and then I think the rest will kind of come in later. Seems kind of reasonable. So I guess we just need to make that thing now. Wayland being a replacement for X11, that's interesting. Only new of X11. Yeah, it's kind of like superior in a lot of ways because like X11 is like heavy and has a lot of stuff that isn't necessary. Wayland is kind of like lightweight, but it's worse in a lot of ways because it's like much more complex, I think. But I don't actually know because I don't know X11 very well at all. Okay, so we need, what do we call it? Swim. We're going swimming. And then we said main, I think. Int, or not int main, what the fuck am I talking? Function main in this language. Return error, hello. Let's just see if that builds. Nope. This thing does need to be public, huh? Are you going to use the UI library you created before? Eventually, yes, but not today. Because, we don't have standard library in here yet, and like integrating that is going to be like another day of work. So, we'll get there, but not right this second. But yeah, that is the plan. Okay, so I guess somewhere we need to create a socket somewhere, right? So I think, how does this work? I guess we can look at the client to figure out how he opens. Which is in W client sig probably. Open Wayland connection. So he looks for these 2 environment variables, XDG runtime dir and Wayland display, and he spits those 2 guys together and just connects to a Unix socket, right? So we need to, I guess we need to look at XDG runtime dir. We need to do this. And we need to make a new file called something in there. So I think that the typical naming scheme, I don't know if this is like defined by spec, but if we look for like Wayland in our environment, right? It's Wayland-0. So I think that we're supposed to like increment the number until like we don't collide, right? So if we look at like XDG runtime dir Wayland star, right? We see that we have this guy here, right? So I assume that what we can do is we can just do like create Wayland socket. And I think that we are going to look at this thing, and then we're going to go like, while true, we're going to try to like start at 0 and just like work our way up. This guy needs some allocator probably, right? Probably. You can jump 1,000, no? Probably, but like, why would I? I can just jump by 1, that's fine. Okay. So here we're like, pick a random number and hope. Y'all are crazy. I would like some sort of determinism in here. Okay, so SDFS open dir absolute, probably? Yeah, probably, right? Is this get env? Does he return a null terminated thing? Yeah, he does. Hype. Var, you know, dir, defer dir close, probably? No, try dir close. Yeah, there we go. And I guess we're gonna be like, dir, can we check like if the file exists? Stat, maybe? Can I just check if like the file exists? Linux check if file exists. Do I have to do like a proper thing? I don't want bash. POSIX. Check file exists. But I don't want bash, and I also don't want these fucking cookie pop-ups or Google integration. Fuck you! Get out of my fucking face! Is it just stat? Like, I feel like it's stat. Oh, access? Feels right. Or can we do just like dir create file and then like say don't create it if it exists? That might be something we can do. Path is this. Can we take in like we don't have our like allocator systems here, but we could use like stood heap buffer, like fixed buffer allocator. We do have this. So const linear alloc for now is going to be like this. And later when we pull in our shit, we can like replace this. But for now, we can kind of do this. And then we have the ability to just like do scratch allocation stuff and not think about it. So we can be like alloc end index, you know, checkpoint is this. And then defer alloc end index equal checkpoint. Now we can just kind of like freely allocate in here without thinking about it. So we're gonna be like stood format alloc print, and this is gonna be like Wayland dash number, I guess, and this is just with index. And then we try to create this file from the path. And here I wanted to check, can we check if, like, can I create a file and be like, don't overwrite this thing? I'm kind of concerned that we can't. Like, should this not fail? What does this call? He calls Linux. Whoa. Open at. Man to open at. You need to use create if you want to create an open. I want the opposite though. Is like I want to like fail if it exists automatically. You know what I mean? But it calls open. Yeah, he doesn't really have that. Oh, wait, hold on. Ensure this call creates a file. If this flag is specified in conjunction with ocreate and path name already exists, then open fails with this. So we want oxcl. Right? That's kind of what we want. Oh, hold on. We're not creating the file with the normal file handle, though. We are creating it with Unix socket shit. Right? So we're kind of approaching this from the wrong angle. We're trying to make a Unix socket. So it's like actually more like std.net Unix. There's connect Unix socket. Is there create Unix socket? Server? How does this work? Where do we get these from? Oh, from like addresses? Init Unix? Yeah. So this actually wants to be more like this with the exeg runtime direct here. Fuck this directory shit. And then here we say like var adder is this, probably const. And then we have like adder listen. And this is where we would get mad. And he says reuse address is false, right? So here he would probably get mad if this thing already exists. And so I guess here we say like, we probably limit the number of attempts here because maybe this will fail for other reasons. So I guess we should just check if it exists, huh? I think we were right to do that before. Fine. Fine. So we'll say, check if this thing exists. And I guess this is actually more like std access absolute, like this, with path. Catch. I guess it depends on the error type, right? I guess access. So if it's file not found, we're kind of chilling, right? This is like the good case. Right? Any other error, return. And then here, we want to continue here probably. Probably. File not found. I guess it's actually this block. Here, we like exit loop. So now we should only get through this. And can you break block with the path? Probably. Probably something like this. Then we kind of pull all like the address shit down here. Yeah. There we go. That seems kind of right. You generally shouldn't be checking if things exist. It's not atomic behavior. Yeah, I agree. But I guess it depends on if this thing returns. Like, if he already returns a, like, it already exists in here as, like, an explicit thing. Like, address in use, maybe. Yeah, maybe you're right. Yeah. This does seem better. You're right. So we should be doing, like, more like this, right? And it's like, I don't know yet. Address in use. Then we continue. Yeah. Maybe like this. If address is in use, else return error. And then if we get through this, we return this. Yeah, it's like this. It's like this. Does that feel right? Maybe. This looks nasty as fuck. But sure. Sure. Yeah, that seems reasonable. Just open it. I mean, I did look at that. I just thought it was wrong when I tried it. Fuck off. Okay, we need an allocator. Var FBA is this. Let's just grab like a page allocator. Let's just like alloc 10 megs off rip for now. And never free it because we don't give a fuck. And then socket is create Wayland socket with FBA. Okay, and then this guy needs to whoa, what's this guy pissed about? Oh, this guy, he wants to return a what? A stud net server. Okay. I guess this is a no break. More like this. Just do nothing. Okay, and then if we have the socket, we should be like socket listen. No? Accept. Sure. And then here, we are going to be lazy. Fix me, hook up to event loop. But that's, again, something that will come later. For now, we'll just only accept one connection. I think that's the easiest way to handle this right now. I think. He's mad because this thing needs to be variable. And then we should be able to be like, I guess we just do this. That's fine. While true, connection. And then we try to like talk to this thing, right? But for now, we'll just do this. There we go. All right. So we should print what we picked. So here it's like, ret is this. And here we should be like, serving, on, sorry. It's hard. Never mind. Serving on, what is this? Path. Okay. So we should be able to now go over to our client. And we should be able to just like try to run that shit and shit will fall over. Right? So we should be able to like, Wayland display is this. Y2? It's a good question. Good question. Yeah, that's a good question. Run user 1001. Wayland. I guess we probably left some open when we. Yeah, that's funny. We're leaving them open. We're leaking. We're leaking because when we control C to quit, it's not running cleanup, right? It's just like siginting and like boom, get the fuck out of here. So that's fine. That's fine. Can we just do this? RM run user 1001 Wayland 1 and this. There we go. There we go. So now we can kind of do this. Boom. Okay. So now this guy's pissed, probably because we like get a connection and then we like get a broken pipe here because the server's just fucking closing it immediately, right? So what we should be doing now is we should be trying to like process these messages that come in some way. So can we just be like, while connection stream, let's get a reader. Let's do unbuffered reading because I believe that Unix socket, like each message will probably come in one packet because like Unix sockets will buffer that way, if I remember correctly. And so we're gonna just go like buff like this, and can we just do like reader interface? Hello, what the fuck? Is it this? Oh, they want me to run function interface. Confusing. IO reader is this. This is like a stream reader. And then we're going like IO reader. Why is this mad? Because this thing is nothing? The fuck? Feels like it should work. Maybe this needs to be var. I don't know. Let's try this for a second. Let's read some. Retrieved is this thing, and can we just like std debug print received this many bytes? Let's start here. I'm sure this is wrong for some way. So he did get an IO reader. So then I don't know what the problem is. Read bytes? I don't know why it's not resolving. Oopsies. RM -F. Zig standard lib. Wrong repo. 15.1. Standard library. IO reader. How do I fucking read some bytes? Read slice, maybe. Read vec. Read slice short. Is it read slice all, and then like what happens if I hit the end of the buffer? Like if I get like one socket or one like a packet with less than buffer size, surely that's fine, right? We do this in Wayland client. What do we do here? We read. Yeah, it seems like it should be fine. Oh, actually, we call it on the underlying stream. That's why. But I guess we'll see. I guess we will see. Read slice all. Let's just see what happens. Okay. I mean, maybe read slice then? Short. Okay. Yeah, they're just kind of both hanging, right? So how do I fucking read like one chunk? Maybe I just don't get to. Maybe I just don't get to. Okay, maybe we read a header length then. So that means let's look at our IO shit. So can we read one header LE? In which case, why isn't it fucking autocompleting? That's so annoying. Okay, in which case buffered reading seems fine. So we'll kind of use this here. And then can we read our header? Struct. There's peak struct. I want like take struct. Take struct sounds right. So hit me a take struct of size of type header little Indian. Okay. And can we just like any format this shit? No? That's cool. What the fuck? Oh wait, hold on. I'm a dumbass. I'm actually just running the wrong thing. That's what I want. Okay, nice. Nice. Okay, so we got a thing. Let's go, baby. Let's go. So what are we supposed to do with that thing? We probably need to like parse the message, right? So how does the client parse messages? What does he do? He has like an event iterator. And he says, get me an event, which has its own like double like circular buffering shit because this was pre-new Zig. But how does he do the parsing is really the question. He calls parse on bindings Wayland event. Okay, so we generate some bindings, right? So we have like based off the XML, somewhere in here, we're gonna have like wayland.zig right here. Right? And he has Wayland events, which are server to client messages, and each of these events implements parse. So now we're going the other way though. We're getting messages, right? So they're gonna send us like, you know, a WL display sync message or something. They're gonna send that to us and we're gonna try to read it. So I guess that means that we need to implement parse on something. So when we write parse here on event parse, how does that work? We have Wayland event, and I guess the reader. We go for each field in Wayland event. If this is the interface ID that came in, then we parse this as that. Okay, so the client is keeping track of which interfaces are bound to which object IDs or something? No, he's checking which interfaces exist at all. Client interfaces get. So we must be registering interfaces somehow? Yes. Okay, so we have like types that we have registered as interfaces at runtime. And we are checking those. Okay. And then we parse the message independently. So this is not that. We, as the server, at ID 0, know that we are a Wayland display. I know that much. I remember. So they are coming in with a WL display message that we previously exposed as our bindings through our bindings as like function sync here, right? It's almost like everything is backwards from what we want, right? So from the client's perspective, we have function sync, and that will send a sync message over the wire. But we, as the server, it's like we want to get a sync message and parse that and send events back. And so what is currently event parse, we would want as a function to send an event. That's the difference. And so I think that our code gen here needs to generate, like it's almost like we want like different generators for the client and server. That's kind of where I'm starting to sit, is like the Wayland server should have one set of generated code and the client should have another, and they're opposite of each other. So I think that means that our existing like Wayland code generator here, we kind of want this to be like server gen, right? So in here, maybe we have like server, okay? And in build, actually, let's just kind of start. Can we, yeah, I guess in our build, we will create that thing. So can we have, we have WLGen somewhere. Can we just install this? Oh, we do. Hype. So we can just do this twice here. We'll do this. I don't think it needs libc link, by the way. I don't think it needs libc. Okay. So let's do this for a second. WLGen server. Okay, so we should have zig out bin, WLGen server, and we should be able to run this on like zig out bin, WLGen server on resource Wayland. What the fuck? What does he expect? His arguments are output path is the last thing. Oh, fuck, he overrode himself. That's so funny. Hold on. He's not, his checking is really bad. Wayland server zig. Okay. So this is him generating some code. And we just need to like adjust this now so that it's different, it's backwards. Okay. So all of the parsing here is going to be the same, I think. It's just what we do with that parse information is going to be different, right? So zig bindings writer is where most of the change is going to happen. So these imports are probably the same. I guess let's see what we do. So we write imports. We write event union, which is no longer what we, I think the event union is like one top level union for all events for parsing, right? So I guess that we have the opposite. So wherever they were doing event unions, we want like function union. I don't know what like the words for these are. Can we look at like the Wayland XML? Do they kind of explain? So they have request. Request is what they call it. So we want a request union, I think. I don't know yet. We'll see. And he is going to go over each interface. That's great. And he's going to say pubconst Wayland request type is an enum that has each interface on him. Great. And his Wayland request is a union over those things. And he's looking for request on this thing. That seems reasonable. So let's see what that looks like. Zig build and this. Can we like, I guess it's like and cat Wayland server. Okay. So now we have, WL display comes in and he's going to be attached to some WL display request. Hype. Super sick. So now what we have to do is we have to say, as we are writing each interface, we are going to write a request thing. And this is not events len, this is requests len. We're going to come back to figuring out how to handle events later, but let's start with this. Okay, so this is write event start is write request start, right? Which is going to have pubconst request. Cool. And then this is going to be like write request field. I don't know what goes in here yet, but we're just kind of doing the same thing. So he is looking at a request, I guess, from request event. Ooh, interesting. So our interface has request events. How does he previously write like the functions? He must have something in here. Requests. He has request event. Oh, wait, okay, hold on. So request event is a request or an event. And he has name, description, args. Cool. So here we're just going like, take the request. Great. Okay. Okay. So we write the request field. New line. Write request type, surely. And he takes this request. Boom, boom. And I wonder if this just kind of comes out for free. It might. This might all just kind of just work. If any request can be parsed. Requests. Okay. We write request parse start. Okay. This thing returns a request now. Write request parsed statement. And this is like parse data response. Great. Dodge reserve keyword. All of this looks like it's probably the same. Write request parse end. All right. And then write events end is write requests end now. Easy. All right. So that like might do something. But I guess we have to do interface writing now. So for each interface that we see, can we look at WL display? So now we have WL display has request, error delete ID, which is wrong. This should be sync and get registry. So we fucked that up somewhere. Because here we're iterating over events here. We want to be iterating over requests. Everywhere we see events here, requests. Boom, boom, boom. All right, 6. We have WL display. He has request, sync, and get registry. Sync, get registry. And in here, we have like parameters that they have. So sync takes a callback. Get registry takes a registry. Hype. And then we can parse these things. So if we see sync, we get parse data response at 0. Ooh, where do these IDs come from? Event name? Oh, I. What is I here? This comes from just like the index of the thing. Is that true? Yeah. Yeah, that seems right. Sure, fuck it. Okay, so now we're kind of starting to be in the point where we could maybe parse their request if we do the right thing. So I think that we probably want to have a server now that's very similar to client. I think we copy paste this whole folder. Haven't figured this out yet. I think this C message stuff probably goes away, and this becomes WL server zig. And then we'll kind of just figure it out from here. So make WL client is now we also have make WL server. He comes from WL server. Boom, boom, boom. Boom, 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 boom. I guess we don't have this like C source file shit yet. Okay, and so now somewhere we're like, make me a WL server. And this thing is going to be fed into our window manager. Right? Surely. Surely. And we add this thing as a thing they can import. Okay. Cool. And now we take a look at this WL server thing. So he's surely going to have a server thing. Who... We're gonna rewrite this a little bit. In fact, maybe... We're kind of only really looking for this parse statement for now. I think. Yeah, let's kind of just see what happens if we do this. So we do need bindings. And our bindings actually have to come from the ones we generated for server, right? So we have to be careful here. This needs to be like Wayland bindings here. Needs to be client bindings. Oopsies. And then we need server bindings as well. So this is make client bindings here. This gets copy pasted to make server bindings for now. And then this is like WLGen. Our WLGen server is like this. Okay. And then everything else here just kind of happens. And we take the WLGen server stuff out of the client bindings stuff because we don't need it anymore. This becomes make client bindings. And then we have server bindings on here. All right. So this guy's mad because he's like, what the fuck are you doing? That's fair. So I guess in here, what does our like response message look like right now? We got one somewhere, right? It said received ID op size. So ID I think is the object ID, and I think the display is special. I think. So I think that we can say if so we like look over these bindings. Hold on. Hold on. I don't think that bindings Wayland event exists anymore. Right? Because we're supposed to be getting the bindings for the server. No? Make server bindings. My bad. My bad. There we go. So now we can be like, let's look over this fields of Wayland request. And if this is display, bindings, Wayland request time, I'm fucking high. This should be, hold on. This should be Wayland request type. Okay, so we're looking for Wayland request type here. And what is happening here? If field this is equal to interface. Oh, sure. So we're looking for like bindings, Wayland request type display, right? Is I guess we're doing this here. Interface is bindings, Wayland request type display. WL display maybe? And we're saying, like, does this thing have a fucking parse function? If it does, let's look at the header ID. And we're going to try to parse this thing. I don't know what data is here. Let's look. Can we look at these, like, Wayland request? Wayland request type. We'll fix that. So W-displayed request. He has a function parse where data is the data to parse. So I guess here we are supposed to read, like this. You know, of like the data size, right? So I guess if we want to like read slice alloc or something, with like header len probably. I don't know if the header includes the size of the header or not. We'll find out pretty quickly. So we should be able to do this. Okay. WGen server. This guy, we had made that mistake again. It was Wayland event type. This is Wayland request type now. Okay. And this is like read slice alloc. There's something along these lines, like read alloc. Alloc. Like there's something in here. Read alloc. Just read alloc. He's mad because oh, my bad. This should be header size. Header ID. Whoa. Oh yeah, I don't know what the fuck is going on here. We should just be doing this. Else unreachable for now. Okay, so it's like something like this. We're looking for a Wayland request, and we are saying like std debug print message is this. There we go. All right. All right, so I think that means that the size contains the header size. It has to, because we're hanging. So now we just do like this. Something like this. There we go! Look at that! We got their first message was them asking for get registry. And they're looking for the registry equals 2. So this, I believe, is them saying, let's look at the get registry call. The first thing that they are doing is they are saying, hey, give me a WL registry. We are telling you that we are going to make requests for a WL registry with this ID. And then later they're going to come back to WL registry here and they're going to like expect some shit. I think it's very likely that we're supposed to immediately start fucking like ripping out these, telling them what they are. So when they call get registry, they can call bind. But I think before that, we start just like slapping out like, hey, we have these things. But let's find out. Let's find out. So I guess all we have to do here. Okay, let's can we just keep the connection open? Can we just do this? Like while true std times or thread sleep, you know. I think 1 million nanoseconds or 1 billion nanoseconds is 1 second. So this guy, the client is just sitting there, which means that we must have to like respond something, or our client is expecting something that he's not getting. So let's take a look at that. Oops. So if we look at like example main or maybe window on initialization, what the fuck is he doing, right? Like he is calling init on the client. He's asking for a registry, and then he's initializing his interfaces. There's no like waiting for anything there. But here he's trying to bind some interfaces, right? So he's just sitting there being like, bro, you gonna fucking give me a registry? I guess, right? He's waiting for W display errors or delete IDs. Or he's looking for WL registry actions, right? So we're gonna send him. Shouldn't this be failing though? This probably waits for anything to happen. Yeah, so I think that right now, if we were to just write something, like, can we just do like stream writer here? Can we go like maybe we just go like connection stream write? Can we just like write nothing just to trigger that guy to wake up? Maybe. That might do something. No. Okay, so let's respond to at least one. Okay? So we need to first of all, we need to take their bind request and like do something with it, right? So we need to write down var interface registry is going to be, I guess there's no guarantee that they have to send us their shit in order, right? So I guess we're gonna have like a probably a hash map that goes from like U32 to interface type. I think. Request type? No, that doesn't sound right. Guess it kinda is. Request type and interface. This should probably be like Wayland interface type. Is probably a better name for this thing. Wayland request type, right? This is Wayland interface type, right? Okay. Wayland interface type. And we initialize it with like our allocator, I guess. And here we are going to I haven't figured out yet. I guess here this is going to return an event, right? Parse event is going to return a bindings Wayland request. Sorry, parse request. Right? Which means he's going to return this thing. Okay. And he is like, I'm parsing this request for this interface, I guess. Wayland interface type. So he's like, yo, you got something here. Op, U32, data, const U8, interface this thing. And we kind of say, you need to parse this thing. You need to parse this thing. So now we call this thing down here. We just say like, yo, parse request, baby. So header up, data, and I guess it's like actually interface registry get from the interface ID, right? Yeah. That's kind of how this is supposed to work. Uh, then I guess we kind of have all of this is going to be like in a handle connection. Connection comes from like a stud net stream, right? And then we can kind of like do all this in here. Right? And then we can call handle connection here. Okay. Seems good so far. And now we can just like fucking bail out here early, right? We can be like, or else return error invalid interface. Right? They fucking ask for something that we don't have. Okay. So I guess here we have like a checkpoint for this guy. And we defer a and index equal checkpoint for now. This guy calls handle connection with our fixed buffer allocator and our connection. Bing, bang, boom. Everyone happy. Not quite, because we have to do something with this rec, right? So switch on the request. If it is WL display, we have parsed. And if we have like switch on parsed, if it is bind, we put this thing in the registry, right? Put I don't know yet. I think that we put the object ID in here, which is this guy. Yeah, bind name is the object. New ID is wait. This isn't what's happening. They're calling get registry. Sorry. So get registry is literally just the registry. So we're trying to say like we have this new thing, params registry, is of type WL registry, right? Right? We take a registry, we say, well, you got a registry, fucking make it a registry now. It's a registry now for you. Okay. And when we initialize this registry, we also have to say, like, we always have a display type at ID1. Okay. Seems kind of reasonable. What is connection here? It's a stud net server connection. Nice. Okay. So now we got some people mad. Expected one thing, found another. So this thing has to return an error. Wait, what's the problem? Implicitly returns. Oh, control flow. Oh, my bad. Fine. Okay, so now he's mad at 65. He's like, what? Switch on this thing, so I have to try here, probably. Now he's mad that we don't have all this stuff handled, so else unreachable for now. So we don't know how to fucking do that. We're not fucking implemented. And this is also unreachable. And unreachable here. I thought I just wrote that. All right. So we got our thing, I think, we should, in here, we should log. Got event any. Right? Let's just make sure. Okay, so we got our get registry thing. And now we need to put this thing in here and start like spamming out the interfaces that we support. So we at least have what? I don't know. Bind. So this thing binds to some interface name. So what does our client do? He calls like bind interfaces and he's just begging for a WL registry thing global. So we are supposed to start spitting out global events, and one of the let's spit out that we have a compositor, right? That's what we're going to start with. So we need to say WL compositor is in here somewhere. Be like, bitch, we got one of those off rip. Okay? Okay. Wrong fucking function. Main. So somewhere we start by we must have to initialize like our interfaces, right? So we have like server interfaces somewhere. And I guess this can be probably another hash map is easiest for now. Maybe this is not how it will always be. But for now, let's do it this way. So we're going to have, this is going to go to some form of server interface of some form. Maybe not. Maybe we can fucking hard code them. We might be able to hard code them because we can just say like, hey, we have compositor at 1. So can we do like something that's like resolve type ID? Can we just take the fucking enum of that we have in our bindings here? We might be able to, right? So we can just say like, we can just say maybe we are trying to emit a WL registry like global. We're trying to send a global event. We don't know how to do that yet. But it's going to be like something like WL registry global. Right? And this thing is going to write a global event probably to the socket that we're talking on, right? So he's going to be like, take this stream writer, right? Something like this. I don't know yet. Right? And presumably we have like a IO writer. It probably looks like this in some way. And so we're like, yo, take this IO writer, and I would love you to write out something with these parameters, right? So this event is going to have like name. And this is going to be the numeric name. So this is just going to be like enum from int of our bindings Wayland interface type WL compositor. We're like, here you go. Here's where he fucking lives. There's like collision here, possibly. So you add 1 here because WL display has to be 1. And we're like, interface WL compositor. Right? Surely. Version. Let's just double check that that name matches up. Yeah, it's like this. Name WL compositor. Great. So we could actually go a little crazier, right? We could go like tag name if we wanted to, but whatever. And what else does he have? Version. I don't know. I don't fucking know, man. What's in the version field? 6. So I guess we should probably just grab this from the fucking XML, right? But for now, I'm just gonna write 6 and say, fix me grab from XML, because it's in there. It's in there. Don't know what to do about it, but it's in there. This should be int from enum. Okay. Okay, so now we just have to like have a way for this to happen. And then also we need to flush at the end of this, right? We need to do IO writer flush because we're writing. Okay, so now we have to implement this. So in our WLGen server, you know, before we had something that was going to iterate over requests and write interface requests. I guess we're going to write events and write interface, write interface event. Okay? And this is going to be like write interface event params. So here's my params. Great. Cool. Then we're like write interface event function. And he creates some function based off this thing, and it might all just be the same. It really might. Reserved word though. Reserved word. So we do have dodge reserved keyword here. What do they do? Sure. We do the same thing. All right, we're getting close. So can we look at the code that was generated? Can we, fuck. Okay. So he is like, I expect self writer params. And he uses his own self ID here. Oh, interesting. So we're supposed to be like registry is bindings WL registry with ID is equal to params registry. Right? So they come in with this thing. And then here we're like registry, like write this shit out. And then flush that shit. Maybe. That doesn't seem crazy. That does not seem crazy. All right. So we sent out a thing. Great. And he's like, yo, you didn't give me the interfaces that I want. Right? So he's looking for a few of them. He's looking for these 4. Right? So we just fucking add those. Right? We're just like, fuck it. We go like 4, supported interfaces. This is going to be a list of bindings, interface type. Yeah. And we're like, we support, compositor. XDGW on base, Z XDG decoration manager. Is that one mandatory? Yes. And he wants ZWP Linux DMA buff. Boom. He's looking for these. And we just rip that shit, right? So you're like 4 support interfaces. And we're like, take this int from enum. And we want the tag name of this thing. And then the version we need to extract somehow. So are we doing anything in like WLGen server? Do we have like version? Can we go look here actually? No. So I think that what we do here is in each of these like types, we throw in like a version field. Right, so you have like write interface somewhere. And in here, can we just be like write interface version? And then we're like, when we write the interface version, we take our interface in, and we are now in some structure, so we can kind of do like, we can just do like const version is this, right? I think. And then here in our main, which we have open twice, which is scary. I think we probably have like resolve interface version. And we can look at like bindings, Wayland interface type, and we're gonna return a like a U32, right? And I think that we can just like walk for, we can do like std meta fields of bindings Wayland interface. And this is gonna be like a field, right? If field, oh yeah. So this is like a, this thing is gonna return union field, and if field type, I guess it's like field name, is equal to interface somehow. If field of, bindings Wayland interface type is equal to the interface, so if we find this thing, then we return field type version, like right, so something like this. Yeah, it's like something like this. And so here we can call like resolve interface version from interface. And this thing is not comp time. I think it's like this. But then he's like, request has no field version. Oh. Oh, gross. Yeah, so we can't. It's these resolve to request. I mean, in here we could just be like, we could have a function that gets the type from the interface here. I mean, maybe this lives in here. Yeah, that might be it. Is that the server generator generates like a interface version function instead of whatever the fuck we did. Right? Instead of doing this, we might want to do like write version resolver. Write interface get interface version or something, right? And then in there we have like function write get interface version. And this guy's like, I'm gonna go over each of these interfaces. And I guess I'm gonna start by being like, I'm gonna be like pub function get interface version, and he's gonna take in an interface of Wayland interface type, right? And he's gonna return a U32. It's kind of like this. Right? Then in here, he's gonna be like, I guess, like, switch interface. And then for each interface, we write out, like, dot something maps to a number. Yeah. Right? Something like this. And this is like interface name to interface version, right? Something like this. And then at the end, this is actually a return here. And then we write out the end, right? Try self writer write all. So this is like close the switch, close the function. That seems reasonable. And so then in our thing, we can just, instead of doing this, we can call like bindings get interface version. Oh no, we forgot some stuff. So this thing needs a new line. And interface needs to be interface. Okay. So now nothing's happening, which is confusing. Oh, because whoopsies. Wayland display. Here we go. So this guy's mad now because connection refused. What the fuck? Oh, there we go. Okay. So our Wayland client is like supposedly up. Would field type help? I don't think so. Because the field type was of the request, not of the field. Or of the, it was like, the type hierarchy was like display, and then he had version, and then he had like request over here. And then up at the top, we had like a union that pointed, like, what went from like interface tag to request down here. So trying to get version from there was like a pain in the ass. So just getting the version out directly is easier, I think. Okay, so he's just stuck. So he must be waiting for something, right? He must be. So what is he waiting for? He like gets all these registries. He comes over here. We have the registry we want. So we've bound our interfaces correctly. Then he initializes his like OpenGL shit. It feels like we should crash here when we call create surface because we don't know how to deal with that, I would think. That's what I would think. Because we just like fucking crash out on anything that's not exactly what we expect to get. Oh no, because we're just sleeping here instead of doing anything sane. So this should be another while loop here, right? Somewhere we're like, while true here, probably? Like, let's read some shit and see what fucking happens. There we go. So now this guy's like, yo, I got unknown WL registry event 1. I don't know how to fucking deal with that shit. And this guy's like, I fucking crash you. Okay. So I think probably this is a bug in server. Got somewhere we wrote event instead of request, probably, right? Unknown. Yeah, it's in like the server stuff. Unhandled. This should be request here. And this should be unknown request. Okay. Oh, RM this. Okay. So now he is saying unknown WL registry request 1. So what is that? WL registry. His things come in as bind. Yeah, I mean, that does seem wrong, right? It does seem wrong. Because as far as I can tell, there should be only one. There should only be WL registry bind. So the fact that he's got something else on there means that our resolution is probably wrong, right? Also, it seems like we're sending all sorts of crazy shit here. We're going fucking wild with it. Right? Like, here we try to read the header size. Then we call parse request on the data that we got out. So we read data. Wait, oh, our header here is the same over and over again. Why? This should be in the loop. This should be here. So that's probably related. Probably related. Much better. Much better. So now we crash in a way that makes sense. So they try to bind to some interface, and we don't fucking know what to do with that anymore. Right? So let's figure that out. So when they call bind, they're saying, hey, I am creating a new object here. So I think this is the same thing where we're getting WL registry request, right? And if we get bind, we need to add that thing to our interface registry. So we say, yo, they asked for interface is params why does this have so much stuff on it? Because this is like name is the name of the object. So that's what we put in name here. So this is, if we want bindings interface type, this is enum from int, and then we subtract one here because that's what we did here. So undo that. We say, yo, params ID goes to interface. Right? That sounds right to me. And then that's it. They're saying, we've bound this thing. When I say this number now, I mean I want to fucking talk to the registry. Okay. Okay. So now, this is like, hey, I got some bindings here. We should log what's happening here. Putting, registering this to this, which is params ID and interface. All right, let's try that. Registering this, registering this, registering this, right? Look at this. Boom, boom, boom. Cool. Here we should probably like check if interface exists and is supported, right? But we can deal with that in the future. Okay, so now this guy's mad because what? We probably are crashing at something. So can we at least before we crash here? Can we write what they asked for? Got request for this. Sure. Okay, so he is making a WL compositor request. So he's probably trying to create a surface. So let's try to make one. Maybe, I don't know, man. Okay. Create surface. Else unreachable. Okay, so here we're like, when he calls create surface, we're just like, okay. So here we have surfaces somewhere, right? We have a surface registry. Who for now, I guess just goes to nothing. We don't know what this is gonna do yet. And here we're like, surface registry, put params ID. Easy. Easy. All right. So now he's like, I freaked the fuck out. XDG WM base is, they're trying to talk to that guy. Okay. We're not above it. So what does XDG WM base do? He is probably trying to call get XDG surface, or he's trying to pong. But we're not pinging, so we don't really care. So he's probably just doing XDG surface. So he's like, I am using a WL surface, and I want you to tie that thing to an XDG surface. right? So he's like, I'm making a new XGG surface with this WL surface. So this is WL surface registry and XGG surface, and I guess I don't know how this is gonna fucking tie together yet, right? But like these things, surely this is like, maybe this points to a WL surface. Maybe we have like surfaces is, you know, something like an array list of surface, right? And then maybe we get like indexes to these things in both of these, right? Maybe. That seems like not insane, right? So we don't really know what goes into a surface yet. But presumably it's something, right? So I think what happens here is when they create the WL surface, we're like, surfaces append an empty, right? And then here we're like, this thing maps to surfaces items len -1, right? Sure. Sure. This guy needs a not getter. And I guess here we have U sizes instead of U32s. And then when he's got the XGG surface, when he's like, yo, I want to get XGG surface now, we have params here. And I think that we just put this in our thing. So we have like XGG surface registry is params ID. And then we have the like WL surface. I guess we have the like surface ID is from WL surface registry get at params surface, or else return error invalid surface. Bing, bang, boom. And this guy's like, okay, now this guy also maps the surface ID. That seems reasonable. Right? That seems like kind of reasonable so far. So both of these guys point, both the XGG surface and the WL surface point to this like surfaces thing. This guy needs surfaces to have at least one thing in him, so he's gonna just say like ID u2 equals 0, just because like we need something to put there. Cool. So now he's like, I fucking got an invalid interface. Interesting. So he called with ID 8. And we're like, we don't know what that is. So, yeah, we do have registering 3, 4, 5, 6. And the fact that this guy's calling with 8 now is confusing. And I think it's because object IDs do not necessarily go to interfaces. Right? This get XGG surface and get WL surface, we're supposed to put those things in our registry as well. Right? So we're supposed to say, interface registry, we're supposed to put this guy goes to WL surface. Right? And this guy down here, he's like, if I'm getting a fucking surface thing, this goes to XGG surface. Right? These are things like we might call these now. Right? So like, this isn't crazy like this. Bindings, Wayland, like interface type. Something like this? I don't know, man. Okay. So now we try to connect. All right. So now we got a request for XGG surface and we don't know what to fucking do with it, right? Because they called XGG surface get top level. So now we need to implement that. Get top level. So he's like, I'm just making a new fucking top level. Okay. Okay. Easy for us. right? XGG surface. He's like, I want get top level. So what does this do? I don't think necessarily anything. Like, what does a top level do? This is like window information for this thing, right? So I think actually in here, we're gonna have, you know, windows or something, right? Probably. And the window is going to have things like a title and a app ID, right? He's gonna like have these things. Allocator, like whatever, right? So when this guy makes this thing, we're gonna be like we're gonna be like Windows, append a thing. So I think that these guys by default are gonna get some like untitled app and unknown app ID or something, right? And we just like rip that shit in here. So we say we have a new window. And we then register this somewhere. So I think that our surface probably. What is this thing initialized with? It's like get top level, right? So he's attaching a top level thing to this surface. Right? So here we have window is going to be U32 or something, right? Or U size, maybe. This is maybe wrong. Like it might make sense for us to more have do we even have to link these? We might not even have to link. I think it might be the other way around, actually. That makes more sense. So we have surfaces. These surfaces are things that we might render from the compositor. We can like rip over all surfaces and render them if we want. And then the window ties back to a surface. Because maybe sometimes we want to do that. I think that makes sense. So here we say in here, surface is params. It's probably the object ID that came in, right? So we need to go like surface ID comes from our XGG surface registry. Get like the object ID from the header, I think. Or else return error invalid surface. Then we create this thing with surface ID. And then we now put this thing in the registry, right? So we have, you know, this guy came in with params ID. This thing is now a XGG top level, is the thing that this is. And do we need to like do something with this window ID? We must, right? We must have some sort of like window registry that is object ID this thing, right? And so in here, we then say like, try window registry put params ID goes to Windows items len -1. That seems right. That seems right. So we point to whichever window is associated with this top level surface. Sure. This isn't compiled yet, but we'll get there. What's he pissed about? Windows append needs allocator here. Fix me, use correct allocator. But like this is like going to be for a problem for future me when we integrate with our proper standard library. Cool. So he's like, got event, top level, set app ID. Cool. So these guys. So I think what's going to happen is since the lifetime of each window is like kind of unique, these things need like their own allocators so that they can hold their own lifetimes, right? For now, what are we gonna do? We can just yeah, because each of these, like the title and the app ID lifetime, are also kind of independent of each other because the client can change these things at any given time, right? So we can't just do like our typical linear allocator scheme here. So let's. I mean, what we would normally do here is we'd have like an allocator here that is like a sphalic stud alloc sphalic, and then we would attach these guys to the general purpose allocator from him. But for now, can we just do like set title here? And let's just for now, because it's easier, we will do like a assert that the allocator vtable is equal to stud heap general purpose allocator vtable. For now. Okay? Just because that's easier. So we're gonna be like, new title is try alloc dupe title. Easy. And then defer alloc free new title. Actually, it was like title buff. Temp title maybe is a better name for this. And then here, we can do stud mem swap. Stud mem, yeah. So this is a pointer to a const u8, and we're swapping self title and temp title. There we go. Now something will get freed. I guess we don't have to do this. Oh no, we do have to do this. Yeah, okay. Cool, and then we do this for app ID. And now that means we need like we actually do need a general purpose allocator now. It's fine. It's fine. What's he pissed about? Oh. And then here we pass in like this, gross, but like whatever. Oopsies, wrong one. All right, like this. Then when we get what is it? Top level. So they're like set app title or something, whatever the fuck it is. Set title. We're like, let me get the title for this thing. So we're gonna say like window registry get from header ID. This is the window ID, right? Here we say window, we get this thing, so windows at window ID. Here we need to check bounds. Do they have, if window ID is greater than or equal to windows items len, return error. I guess this is kind of like unreachable. Which means that this will crash automatically. So we don't, with this, yeah, this should never happen because the window ID is handled by us. And if we're managing that wrong, it's like a coding error. Set title to params title. Easy. This thing is mad. Why? Can we just do this? Like, const GPA vtable is comp time block. Var GPA is stood heap general purpose allocator. And then can we go like GPA allocator? Can we do that? I don't know if that's allowed. What do you mean this is double pointer? Oh, oops. I see. We're swapping const u8s and we pass pointers to those things. Sure. What the fuck? Swap takes 2 pointers to t. T is a u8 slice. So we're trying to swap self title and temp title. Am I fucking stupid? Oh, they're not const, I guess. And this is const. This should be like this, which means that this has to be initialized mutably. Oh, gross. Maybe more like this. Yeah, that's a little better. I guess this has to be like this by default, because if it'll try to free these when we set them, which is bad. Okay, cool. Oopsies. Okay, so he's mad at set app ID because we did set title, not set app ID. But set title and set app ID are like the same fucking shit. All right. Whoa, maybe they're not that the same. Oh, because this vtable thing was wrong again. Okay. Temp. Boom. All right, does that compile? It does. Wayland display. Okay, so then the app ID has been set, the title has been set, and they're trying to get top level decorations. What the fuck is that for? Who fucking knows? We just gotta fucking follow it one by one. Okay, we gotta fucking hurry. I gotta focus. Focus up. I would love to get to the point where at least we are not crashing on init. I don't know how much more of that there is, but it feels like we gotta be close. So he's calling get top level decoration. Okay. Get top level decoration. This is in somewhere else. This is in some other protocol. Where is it? XCG decoration in here. So he is returning a top level decoration which has destroy set mode, unset mode, so it literally doesn't fucking matter. I think it's just that in Kwin, this did something. This changed behavior of Kwin. So I think that we just be like, fuck off. Whatever. You know? I'm pretty sure that that's good enough. Okay, now he's looking for... He's trying to commit the WL surface. Okay. We're getting pretty close, I think. Okay, for now, I'm literally just gonna ignore everything associated with the WL surface. Because I think that we, like, don't handle that right now. Let's fucking go, baby! Let's go! So here, he is probably waiting for us to send the configure event back, if I remember correctly. And then he'll start rendering. So I think that here, if we see a commit, I think that we are supposed to respond with something. We're supposed to go like, I guess we need to look like at our XG surface registry. WL, so the WL surface has to go back to XCG surfaces, I think. So I think that our surface needs backlinks, or at least XCG surface ID. I think. So here, when he kind of puts this in here, he's gonna go like, this thing's null at first. Cool. And so then when he attaches the XDG surface to this thing, here we look at the surface ID and we say like surfaces at surface ID. No, it's not here. It's when we add it to the XCG surface registries, right? So we say go surface items at surface ID. XCG surface ID is params ID. So now, when they call commit, we can get the surface out of its thing from looking at the WL surface registry, you know, from header ID here, or else return error invalid surface, right? We look at surfaces at this ID, right? We look at the XCG surface ID, return error invalid surface, right? And then we can like create an XCG surface interface from this thing, I think. So we should be able to be like bindings, XCG surface with ID is XCG ID, right? XCG surf. And I think that we can be like XCG surf configure. We are fucking ready to go, right? And what is serial here? What does this, do we use that in the client at all? Oh, sorry. This is the wrong thing. Window. Ack configure. So he acks that shit. But we can just ignore that. Fix me random number that is confirmed in ack. But for now, fuck it. You know? He's mad that area union is ignored. But then we should have on XDG surface, ACK configure, just ignore it for now. And if we did this right, then I think that the client should start spamming us. That would be ideal. He gave us a frame. Oh, so he's waiting for us to start calling back, I think. I think we need to say... we eventually are going to let him know that we are finished with this frame. So in our current world, we just immediately like rip that shit back, right? Frame. So we're like, yo, bitch, we are donezo. So this is the surface ID. No. So who? It's WL buffer release here. Whoa, what the fuck? WL surface frame callback. So he frame request for notification when it is good time to start drawing a new frame by creating a frame callback. So how do we use this? We construct a WL callback out of this thing and just rip it. I think. So I think we're just like bindings WL callback with ID is params ID. And I think we just rip this shit. Try callback. Oh, here we should probably are we flushing our writer here? We should be flushing here. IO writer flush. Oops. Be careful about this. So we're saying like done. And can we just be like callback data equals 0? I don't know what this is. I think this looks kind of right. Just rip that shit back. Okay. So we're getting closer now. So now he's trying to render. He's like trying to give me some DMA buffs. So can we just ignore that shit for now? Can we just ignore that shit for now? He creates, he adds. Yeah, we probably can, right? I think. Because we're not actually doing any rendering yet. Oopsies. Okay, and then we got an unreachable hello at Linux DMA buff. So then he's trying to like, he is trying to give us this thing. He's trying to call create params. Then he's trying to like create he's trying to commit this thing somewhere. And so we're going to be losing buffers, which is bad. But that's okay for now. We might end up, we're only going to run the client for a very short amount of time. Because we don't want to accidentally like use all our GPU memory and never release it. Invalid interface here, because we need to register the interfaces when they get them. So when he calls create params, we need to register this ID. So we need to be like interface registry put, you know, params ID is I guess this is like switch on the params. This is parsed, switch parsed. And if it's a whatever the fuck this thing is, this is a create params. We need to write this thing down. Right, so we have like interface registry put params ID goes to zwp Linux buffer params v1. Easy peasy. Then we're going to get some buffer params in here, and we're going to ignore them. Okay. Swap failed because... Oh, because he ran into buffers. Wait, okay, so this is good. So we should see in here him attempting to render, right? So we should probably see a couple attempts to render, and then he runs out of buffers on his side and like gives up because we never release them, right? So he comes in here, he's like, yo, I've got a buffer here, please fucking render that shit. And then he does it again. He goes like, please, here's another buffer, fucking render that shit. Sick. Oh, and then this commit. We should probably fix me. Probably don't send this every commit, lol. Only on the first one. But I think we finally, 2 hours later, have complete init handshake. We have got to the point where he is trying to render, and I think that that is a okay place to call it today. So we have code here where we have like the initialization ready. We have Wayland message parsing on the server as well as Wayland message dispatch on the server. We are definitely not handling this main loop correctly, and the architecture of this whole thing is fucked. But theoretically, we have everything we need to start rendering from... Where is our picture? Kind of like from the talking over the socket side, right? All of the like render to the computer screen side is like not even started yet. But that I think we can do tomorrow, and we'll be in a pretty good spot. So yeah, cool. Thanks for watching, guys. Oh, I missed a few messages. Interesting ones from the Raggy, probably. You probably want to go implementation. But generally, it should be popping up doctors. Oh, you're talking to someone else. All right, cool. Thanks for watching, guys. If you like what we saw, we stream most days, 12:30 to 4 o'clock Pacific time. It's 4:30 now. We went a little bit over. We are working on this Wayland compositor now. We probably will be on this for a little bit. So if you want to see that, check out the YouTube, linked in the Twitch description. You know, if you want supplemental content as well as to support the stream, Patreon, YouTube members, Twitch subs are all good places to support. You could check if you have a Twitch Prime, use it for free maybe, you know. And also GitHub sponsors is another good spot. I get more money there, but you don't get any supplemental content if you sponsor on GitHub, just the way it's like set up. But if you don't care about that, that's a good way to support the stream. The stream will end when I run out of money, right? So having, you know, every dollar extends the long-term lifetime of this by some amount. Okay, that's it. YouTube, peace out. Twitch, let's find someone to raid.